My name is Václav Turček. This is Jeffrey Richter.
Hey.
Hey, got a good turnout today. We were actually trying to figure out if it was because Jeff's name is on the talk or if it was because my name wasn't on the talk. But I gotta say, since my name's up there now and no one's left yet, that's probably not it. All right.
Okay. So quick introductions. I'm Jeff Richter. I'm a Microsoft software engineer now. I'm also a co-founder of a company called Wintellect. We have a training and consulting business. But most people are familiar with me from the various books that I've authored over the years. I put my 3 most recent books here on this slide. And then down below is my contact information. For you, I should have changed it. It should be jeffrey@microsoft.com, not wintellect.com. For you. And then if you want to be my friend on LinkedIn, I will accept anybody. I am desperate for friends there. And
is that why you accepted me?
Yes.
Ah, jeez.
Yes. And then my Twitter handle down below. And now,
right.
Without further ado.
I'm Václav Turček. I'm a program manager on the Service Fabric team. I have not written any books, but I do write a lot on Stack Overflow, so if that counts, cool. And I don't have any, I don't really do a lot of social media, but you can find me on GitHub. Come check me out there. You can see some of the work I do.
Okay, so the way we structured the talk, all right, thanks.
Really want that.
Sure. The way we structured the talk is that I will talk a little bit about kind of theory about microservices in general, and then Vaz is going to take that theory and show how it applies in Service Fabric, these kinds of concepts. And so we hope that it's kind of fun that way, and we'll be going back and forth throughout the session. So we'll start off just by talking about, exactly what is a service in general. And a service, which, at the bottom of the slide I mentioned, what we call a microservices architecture. So that's what we're kind of leaning towards. A service is a body of code that you create in order to solve some kind of domain-specific problem. They're typically built by small teams using some kind of technology stack, and one team could build a service using something like .NET, another team could build a service using something like Java, or Node is very popular as well, and the team can choose whatever technology stack they want to use to go and build the service that they're trying to create. It exposes features to callers via a well-defined API contract, and we'll be talking more about that as we go through this session. Ideally, when you create these services, they would degrade gracefully when a dependent service fails. That's typically a hard thing to do and to test and to try to think about. So if a person's trying to log in and my authentication service is down, then they can't log in. But is there anything they can do with your service even though they can't log in? And in an ideal world, you would let them do a bunch of things. Maybe they can browse products, for example, but they can't put them into their shopping cart because there's no identity associated with them at that time. So that's the kind of thing that you have to think about, which a lot of people don't necessarily think about. Services can be upgraded and scaled independently of other services, and as we'll talk more about later too, this is a real critical part of why you want to break things up into microservices, is so that you get this kind of independent scaling and independent deployment of the service, so it can be upgraded. One service can be upgraded without having to upgrade the other services that depend on it. And dividing a big service, which sometimes people refer to as a monolith, into smaller services is often referred to as a microservices architecture, right? So you don't build microservices, right? It's an architecture really, and then you're building services that adhere to that architecture. Okay. Now, I've been reading a lot and watching a lot of videos and going to other people's talks at other conferences, not this one, where people talk about a lot of the benefits that come when using a microservices architecture. And from the experience that I have of building a lot of distributed applications over the many years, I think some of these benefits are really more like myths. And I don't really believe that they're true. And I think that we could have been doing these things for years, and we didn't need a microservices architecture to do this. So I'm going to share my opinion of some of these, what I will be calling myths as opposed to benefits. So a common belief that is spread about microservices is that they offer small, easy to understand and manage code bases, and that if you build microservices, that you will get this. Well, quite honestly, I think we've been doing this for decades. That's really what object-oriented programming was all about. You build these classes, which are small, self-contained units of code that are easy to manage and easy to understand. So I think we've been doing that for a really long time, and microservices isn't really something that enables that per se. We've also been able to package these classes into libraries, in the Windows world, dynamic link libraries, for example. And so while microservice architecture can maybe force developers into this because you are living in your service, You can have that kind of self-discipline today as a developer and have been doing it for the past several decades. So I don't think this is really a feature that you get with microservices at all. I think just some developer discipline is all you needed, and we've been doing it for a long time. And a benefit of using object-oriented programming in languages is that if you change something in a DLL or in a class, then when you recompile the code may not compile if there was something that broke. You changed the signature of an API, for example, or you spelled something incorrectly. And this kind of compile time type safety is a very positive thing to have. It allows you to detect bugs early before you start deploying code. Another myth is that a failing service doesn't impact other services. A lot of times when people talk about microservices, they say, well, when some service dies, the other service keeps going. Well, many services have really hard dependencies on other services in order to keep running. And therefore, that's kind of a myth and gets dispelled as well. And it is hard for developers to write and test code that gracefully recovers when dependency fails. A lot of developers don't even really try it and make sure the catch blocks are correct. And the example I gave earlier of the authentication service being down, and then how do you let them still look at the products that you're selling, even though they can't put things in their shopping cart. A lot of times people don't think through those scenarios. So it does require extra effort to get you to this place. Just being microservices doesn't make that just magically happen for you. And we run multiple service instances, so there's no such thing as failure. In a lot of these cloud worlds, and it's certainly true of Service Fabric, you usually have multiple instances of the microservice running. So if one of the instances fails, the system that you're using will restart that service and keep it running again. So it's not like it's not running for a long period of time. And there's multiple instances of it, so then network requests can go to an instance that's up instead of the one that's down. So again, it's not really this failing service doesn't impact others is kind of a myth as well because of that. And with a monolithic architecture, all of the components are either up or down at the same time. So you don't have to worry about this recovery code or what happens if this piece isn't functioning and this piece is functioning. And then you might say, well, something might go down. But again, the system that you're using, like Service Fabric, will automatically restart that for you, and you might have multiple instances of it running in parallel. So if one instance does go down, client requests could be directed to another one that's up. So it's not really a big feature of microservices to have that. So what I've been thinking about this problem a lot about microservices and when should you use them. And I have, my current thinking anyway, is I've concluded that there are 4 reasons to break a monolith down into microservice architecture. And as far as I can tell, these are the only 4 reasons I can come up with. So the first reason is you want to have different pieces of code that scale independently of one another. For example, here I show an example of a photo share microservice where requests are coming in for people to look at photos or perhaps to go and upload photos. And when they upload photos, and only when they upload photos, we need to go and create thumbnail images of those photos. So we have a separate service on the right, which is the thumbnailing service. And at certain times of year, if people are just looking at photos, we don't need a lot of the thumbnail service. At certain times of year, like holiday season, people take more photos, we might need to scale that up and add more instances to it. And then when the time is over, we can go and scale it back down, and maybe we don't need as many as we needed before. So by making these 2 separate microservices, we can scale them independently of one another. All right, so that's the first reason. The second reason to use microservices is different technology stacks, which I alluded to earlier, where you might want to write one part of your program using some technology stack, like Node.js I have over here for the photo share service, and then maybe use .NET to do the thumbnailing service. And then we will communicate between these 2 microservices using some kind of network communication. The third reason is to have independent deployments. Now, this is a lot of times what people think of as the holy grail of microservices, where, let's say, the guy or the team that's responsible for the thumbnailing service, right now they have version 1 deployed, and then they want to go and make some changes to it, so they're going to bring it down, there we go, and bring up version 2 of the service over here, and version 1 of the photo share service, that just keeps running. And this is great, of course, and it gives you this agility, but there's also this downside of the lack of testing that may have happened. If these are two different teams, this team over here that's creating the thumbnail service can go and make a new version of it, and then they just deploy it, and maybe they never tested it with the photo share service, and possibly they broke some behavior. So there's some goodness here, but there's also some badness here, and your mileage may vary depending on what it is you're doing. The fourth reason that I identify to enable or establish a microservice architecture is a fairly esoteric one. So I don't think this is going to be the most common. I think these other three are far more common than the fourth. And the fourth one is conflicting dependencies. Imagine that we're building a monolithic service, which is this photo share service, and it uses some library, which I call some shared lib, and maybe it has a dependency on version 1 of that shared lib. Then it takes a dependency on this thumbnail DLL, another library, and the thumbnail code has a dependency on the shared lib, but it's a different version, version 7. Well, a lot of times, depending on the technology stack you're using, you can't have two different versions of a shared library in the same process, right? And so now you have some weird, dependency issue that's going on. So a way that you can fix this, of course, is to break it up into microservices, where you have the photo share service using shared lib, and that can be version 1, and then you have the thumbnail service, and that's also using shared lib, and it's using version 7. And these are the 4 reasons that I can think of why people should split things up into microservices, and they're only 4 that I can think of in the past 6 months or since I had this revelation. All right, so now we'll switch over to talk about microservices in Service Fabric, and I turn it over to Vaz.
Thank you. Okay, so we'll step back a little bit before we get into the 4 reasons why you should use microservices and not. Let's first describe what a service actually is in Service Fabric specifically. And so we have this notion of service types and named service instances, and I'm going to focus a lot on this concept in this talk because it's really important. It's important because this is actually how you do things in Service Fabric, but you can actually take advantage of this to accomplish a lot of the things that Jeff was talking about. So the service itself, the code that you write ultimately is just an exe. It's just a process that runs. So there's nothing special about that. We didn't make up anything new there. Oh, and now of course in containers as well. You can run things in containers now too. But really it's just an exe. But the idea of a service type and named service instance has more to do with how we package things up in Service Fabric and this kind of first class notion that we give to a running service. So in other orchestration engines, for example, you might just have containers that get orchestrated out and run on VMs or something like that, but there is no real notion of an application or a service. And so in Service Fabric, we actually have this defined, it's well defined. So the service type, this defines the behavior of the service, kind of like a class that you might write in Java or C#. So that is the definition. You write your code, you compile it, and you create this kind of package out of it, and that's what the type is. And then the named service instance is when you essentially go and instantiate that type. So kind of like creating an object from a class. So I write the class once, and I can create 1,000 objects, and they each have a different name, right? So you assign a variable name or something like that. That's what the idea is here. So you can do this in Service Fabric, and this is a really interesting thing that enables a lot of cool scenarios, and so that's what we'll show you today. So here's what a view might look like in a Service Fabric cluster. You may have multiple service types, and these are essentially the definition of your different microservices. So each one of these service types would do a different job. So you might have one that's a web service, you might have one that does something with users, you might have a service for authentication, session, whatever it is. Each of those types defines a different job or a different type of work that those services do. Now, what you go and do is you go and create instances of those things, named service instances, and we call them named because they have this name format, which is this fabric / application name / service name. That's a fully qualified name that you give to the service. And so every one that you create gets this fully qualified name. Now on top of that, we also have this notion of applications. And this same principle, you have an application type and you can create a named instance of that application type. Okay. And the application type is really just sort of a logical grouping of the service types, and the same thing with the application instance. It's a logical grouping of named service instances. Now there are some important differences, and we got a couple slides that'll outline that, but just all you have to know right now is that those concepts kind of exist, okay? So the interesting things you can do is you can actually create these instances on the fly. You can create service instances, named service instances at any time. And this is an important distinction because it's not a deployment time decision necessarily. It's not that you write your code, you compile it, you package it, and you send it up to Service Fabric and say, I now have these named service instances and I'm done. That's not really the case. There's really no difference between creating something statically or creating something dynamically. We don't really make that kind of distinction. You're always just creating named service instances, and you do this through an API that Service Fabric provides. So that means you can do really interesting things. Like, for example, you can have a service whose job it is to just create more services. So you can ask Service Fabric, you can say, I want 3 new named instances of the job runner service type at any time. Not deployment time, but any time at runtime, you can do this, okay? And Service Fabric goes, yeah, all right, sure. And goes and creates those new things for you. Now you have new services up and running. And you can do this indefinitely. You can create hundreds of these things, thousands of these things in a cluster if you want. And this is a very, very, very important way of working with Service Fabric. This is actually, I think, one of the biggest differences with Service Fabric and other platforms. One of the things you get with Service Fabric that's pretty unique is the ability to actually do this. And so what I want to show you is a very simple demo of how you can use this technique to do a microservices-like architecture, okay? And this is going to be very simple. It's just going to be two services. One's a controlling service, and one is kind of this job runner service. So I have this idea of I want to run some jobs, and I want to kind of create them on the fly. And we've seen folks use this for a lot of different things. So processing jobs, for example, you want to process tax returns, you want to process something like that. You basically want to spin up a job, do some work, and then let it die down, okay? Or maybe gaming sessions, whatever it is. Or even in multi-tenancy scenarios where you have users that come in and say, I'm a new user and I want a new service to handle my, whatever it is that your platform is offering your users, right? So you create a service instance or a named application instance for them. So the way this works is there's a management API. The management API has 3 different languages that you can essentially use to talk to Service Fabric to do this. You can do it over HTTP. You can script it through PowerShell, or you can do it programmatically through C# and Java. So if you're running it inside of a service, for example, you might do it programmatically. Now, let's jump into the demo. Oh, that was cool. Okay, my taskbar is gone again. So this is going to be real simple, and if you want to follow along, actually, you can, because I'm not going to start with a pre-written application. I always find it difficult to follow when someone throws me right in the middle of their code that I've never seen before. So we're actually going to start with a brand new project here. And we'll just go through the usual Visual Studio thing here. And we'll just create a new guy here. We'll call him the job demo. All right. And what I'm going to do, I'm going to choose a stateless service for this. We have lots of different types of services that you can do in Service Fabric. I'm going to go with stateless just for kind of simplicity for demo's sake, but everything you see here works just the same with stateful services as well. So we'll start with the stateless job service, and I'll just go and create that. Okay. So you've all seen this before. Visual Studio is just creating some files, creating the application, creating the service, no big deal. This is all kind of boilerplate stuff. And while that's creating, there we go. Okay, so I just got my application, and I just have a service, no big deal. So I'm not going to touch the code here. I'm going to leave it as it is. It's just, oh, hi, Sean. There we go. So I'm not going to touch any of this code. This is just the standard stuff that comes with the template. It does something about counting, doesn't matter. All I want to show you, though, is how we can go and create instances of these things on the fly, okay? So what we're going to do is we're going to go and build this and package it up, okay? So I'm going to take this guy. I'm actually going to do something interesting here. I'm going to go into the application manifest, and I'm going to make a little change here. So we have these default services here. Now, when I was talking about static versus dynamic, this is the only place where it really actually kind of makes a difference. The default service does this interesting thing where it takes the named service instance and defines it as part of the service type. And basically what that means is that every time you go and create an instance of this application, you're automatically getting an instance of this service. And it's great for some things because sometimes your application doesn't make sense without a service in it. It's just going to be empty. It won't do anything. And that's exactly what I'm going to do. So I'm going to delete this out of here because I want to go and create these things at runtime. I don't want it to automatically show up as soon as I start the thing, okay? So we'll just remove that, and that's totally fine. Now, I'm going to go and publish this locally. on my local 5-node cluster. Okay. And that's just going to go through the usual steps. It's going to build it. It's going to package it. If you're not familiar with these steps, it's pretty simple. It's just kind of creating a packaging format, which is basically just a directory structure. It does this thing where it goes and copies the package up to the cluster, and then it does this thing called registration. And registration is a really interesting part. Registration means that the cluster is now aware that this application type and service type exists. So if we go into the Explorer, you can see now I have, here's my job demo. Okay, so this is my application type, and this is a named instance of that application. Now, you'll notice it has no services running, so it's not doing anything. My XC hasn't started. It's not doing anything. All we have here is Service Fabric is aware that there is this application type, and it has a service type, and it has a version, and it's aware of it. Now I can do the interesting things like create a new instance of the service. So down here I have no services, but I do have a service type. This is my stateless job service type. And now this create button, here's the interesting thing. I hit create here, and this fancy little UI, I get this form. What this is actually doing is it's talking to Service Fabric using the HTTP management APIs. Those HTTP management APIs are public, documented. You can use them to build a very similar kind of UI. That's actually exactly how we built this. There's no magic here. This is using all the same public APIs that you have access to. So real simple here. I can just call this, let's call it, what did I want to call it? From SFX, Service Fabric Explorer. And I'll just hit create. Okay. So I noticed I'm doing this at runtime. I went and registered this whole thing. It's ready to go. And at any time, I can now go create instances of these services. So I got one here. I can also do this through PowerShell. Real simple. I go into PowerShell here. And if this is too small, let me make that a bit larger. So same deal here. You saw all those parameters that I had kind of filled out in an HTTP form. I'm now doing it all through PowerShell instead. So if you're doing some scripting or something like that, you can do it pretty easily. So you just run these scripts, connect to the cluster. Again, I already have my service type registered. So all I'm doing is saying I just want a new instantiation of that service type. And it's going to go and create it. Okay. So real simple, real easy to follow along with. And you can see now under services for inside this application, I now have 2 named service instances of that type of version 1.0. So real simple thing, but a very powerful concept because you can do this, you can use this in all kinds of scenarios. And we'll show you a couple more in a minute, but we'll stop there for a minute and we're going to move on to, not that one, Shift F5, right? Mm-hmm. Okay. All right, so we'll leave that as is for now, and then we're going to come back to that demo and we'll do a little bit more with it once we get through application upgrading. Clicker's right there for you.
All right, so it's back to me.
Back to you.
Oh, I have to click.
What you need. Oh, yeah.
Okay, so you're always going to get to a point where you have version 1 of your code running somewhere, and then you're going to get to a point where you want to upgrade it to version 2. So I have identified 4 ways for people to do an upgrade of a service from one version to another version. So this is the theory part again. So the first version, which I refer to as the delete and upload scenario. So here I have a production cluster, and it's running a bunch of instances of my microservice, and it's version 1 in there. And of course, one option that you have is you can go and bring that whole thing down, and then, but now you have downtime, and your customers are not able to access the service anymore, or the clients cannot access the service anymore. Then you go and you upload version 2, and now your clients can be able to access it again. So this doesn't require any additional hardware to do this, right? You're using whatever existing hardware you have in the cluster to do it, so it's a fairly cheap, in terms of money, way of doing it, but you are losing, client requests coming in, and that might mean the loss of money for you if you sell things on your service. Another way to do it is with what we call a rolling upgrade. So here I have a production cluster on the right, and it has 6 instances of my microservice running in that cluster, all version 1, and then I now want to upgrade them to version 2. And we can do that with this rolling upgrade where we bring down some V1s, make it be V2, bring down V1, bring a V2, and so on. When you do it this way, again, there's no additional hardware because you're using your existing cluster that you have, but there's no downtime to your customers, your clients that are trying to access your service, because at any given point, you only have 2 instances down in this example. So 4 instances are still handling client requests, and then the other 2 instances come back up, and then we do the next 2 instances, and so on. And a lot of times, orchestrators that support this, they also support rollback. So if after upgrading there's something wrong with version 2, you can roll it back and bring back version 1. And we'll talk about this more when we talk about Service Fabric and how it fits into the picture here. Another 2 ways of doing upgrades are the more expensive ways. So here, I have a production cluster, and it's running 6 instances of my service version 1, and then there's usually a load balancer that you have in front of these clusters. And what you could do is you could stand up a whole other cluster with a whole other set of virtual machines. So you're now paying, for twice the number of virtual machines during this process. And then we put version 2 of the code in that new cluster, the staging cluster we'll call it. And then after it's up and running, and you could even test this code to make sure that version 2 is good before any customers are hitting it. Then after you feel confident in it, then you can do what's called a VIP swap and tell the load balancer to direct all traffic to the new cluster instead of the old. Then, after you feel confident that everything's working fine, you could actually bring down the old production cluster, and that'll end up saving you money. Or if you notice problems, then you can do a VIP swap right back to the production cluster, and then you can bring down the staging cluster or bring up version 2.1 or something if you have some bug fix in there. And then the 4th way is kind of similar. I call this the controlled migration pattern, where we have our V1 production cluster that has all these V1 instances in it. And then there's that load balancer in front, just like we have the load balancer here. But then in Azure, we have this thing called the traffic manager. And the traffic manager is another service that can direct things to different load balancers. And so you can stand up a version 2 production cluster, put your version 2 instances in it, and then program the traffic manager to send, let's say, 90% of the traffic to the V1 cluster and 10% of the traffic to V2. And now you have a slow way of doing migration. You can slowly move customers, and then you can change the dial and say, well, instead of 10% going there, now I want 20%, now I want 25%, now I want 50%, and then you can slowly migrate. And then, of course, if you don't like what you're seeing, then you can turn that off and send all your customers back to the V1 cluster. Again, it's more expensive because you're paying for double the number of VMs hours in order to do this. But eventually, after the transition's complete, you can bring down the original production cluster, and then that ends up saving you money. On this slide here, I show a table that kind of compare and contrast these 4 different upgrade patterns. Those are the 4 columns. And then on the left-hand column over here, I show various features that are related to those 4 different upgrade patterns. Now, Service Fabric supports a unique feature, which is the ability for you to have stateful services. And if you are using stateful services in Service Fabric, you'll notice that that's the only one with a yes in the rolling upgrade. In other words, you have to use rolling upgrade with our stateful services in order to maintain the data. There's other ways that you can test different versions of your stateful services, but then ultimately, after you've done the testing on some fake data, in order to get access to your authoritative data again, you will have to end up using a rolling upgrade. I also have a bullet at the bottom here that says that some of these upgrades could be done one way and some another way. It's not like you have to choose one and stick with it forever. Some things you can do a rolling upgrade, some things you could do a VIP swap, some you could do a controlled migration, and that's up to you for however you want to pull that off. All right, so that's the theory part, and now how it applies to Service Fabric.
Yes. Okay. So I mentioned there's some important differences between applications and services here, and one of those big important differences is that upgrades actually target the application and not a service. So when you go and do an upgrade, you're saying, I'm upgrading this application, and that means the services within it. It doesn't mean you have to upgrade all the services within it at once, but the target is always the application. Now, we talked about rolling upgrades, and then we also talk about, so if you have rolling upgrades, what if you want to do some side-by-side testing first, right? So I just wrote a new version of my application, and I'm not quite ready to switch all my users over to it yet. I just want to kind of put them up side by side and do a little A/B testing. So this is, again, where Service Fabric features of types and instances comes in, because as soon as you go and register a new version of that application type, what you can do is you can leave the old one running. So you have a version 1.0 here in this case. I have version 1.0 of the application running. I'm going to go and register version 2 of that application now, and then I'm going to go and create an instance of version 2, but I'm going to keep one up and running. Okay? So now I got 2 of these guys side by side. And this is super easy to do. This is real simple. It's just a couple commands that you have to put in there. There's a little bit of work on your part that you have to do if you have, say, for example, a web application or something, and you want to be able to hit them on the URLs or something, you might have to use different URLs on each of them so you can test them side by side. But other than that, it's all kind of built into the platform. The platform just allows you to do these things, right? And then when you're ready to actually do the upgrade, you can go back and target the one that's running and then do the rolling upgrade on that. Now, why would you do it on the one that's running on 1.0 instead of just keeping the 2.0 one? If you're stateless, it doesn't really matter. And like Jeff showed, if you just want to migrate your traffic over, you can do that. The reason you do a rolling upgrade in place on the original one is if you're stateful. Now, if you're stateful, all of your users' data is in the instance on the left. The instance on the right doesn't have any of their data because it's all co-located. So I can't just move them over to version number 2 instance over there because none of their data will be there. They're all over here. So I got to do a rolling in-place upgrade. And that's why we stress rolling upgrades over doing regular VIP swaps in Service Fabric, is because of that statefulness. And it turns out even if your services are all stateless, the system services that are running in Service Fabric that are keeping your services alive and doing all the cluster federation and all that important stuff, those themselves are stateful. And so we need rolling upgrades to be a first-class citizen in the product specifically for that, but also for your applications as well. So it's very, very tightly integrated. Now, let's see how it actually looks. So I'm actually going to run through this real quick. I'm going to go and add another project. We're going to go back to our demo that we were doing earlier. And what I'm going to do is I'm going to add a new project to it. I'm not going to actually write this one. I have this one pre-written out, so I guess you can't follow along too far. But it would be pretty boring to just sit there and watch me do it. So we'll just add an existing project. Now this one's going to be, this is just a web interface. A simple web interface project. Here we go. And this is an ASP.NET Core project, stateless service. And I'm going to add it in here once it loads. And then what I'm going to do is I'm going to go under services here in the application. So Visual Studio gives you this kind of application notion in here, and it lists out the services that are in that application. I can just go and add an existing one, so we'll just do that. So I've already got this one here. Okay. Yes, that's okay. All right. Now, what I'm going to do is I'm going to go and take the existing application that I've deployed, and I'm going to leave that one there, and we're going to do version 2 of that. And version 2 of that, what we've done is we haven't changed the job itself. The job is still running the way it is, but what we've done is we've added another service type. So imagine you have an application, you've got 10 microservices in it, you want to add a few more services to it, you can do that as well. An upgrade can do that, so you can add new services to it. So that's what we'll do here. Now I'm going to do this kind of manually so that you can see how it actually works. So I'm not going to do the magic of Visual Studio here. What I'm going to do is I'm going to package it up here. So there's a command in Visual Studio just to do packaging. And all that does is it just builds out the directory structure that Service Fabric needs. All right, now that's done. No, looks like it failed. Why? Service manifest, fine. Ah, yes. So let's step back. I have to actually add this in the application manifest. So this is an important step here. Now, what you see here is I have in the application manifest, I'm defining which service types are actually allowed, or well, which service manifests are allowed to be in this application. The service manifest, if you don't know, is just the thing that kind of describes what the service is. It's got a little bit of description in there. It's a small XML file. When I said that the service that you write is just compiled to an exe, the thing that sits next to that exe is an XML file that says that exe is my service. It has this name. It has this version. That's all that is. So what you do is you go and add a new one here, and we'll just say new service manifest name. And I had a name for it written down here so I wouldn't forget it. It was web service package. All right, great. And the version, since we just started this one, we're just going to do a version 1.0.0. Okay, that's all we need to do. So that's it. That just tells Service Fabric, yeah, it's got this other service in it. Okay, now one more thing we got to do now. So I want to do a version 2. So I'm going to go in here, and I'm actually going to change the version of the package here. That's in manifest version. So here's the interesting part of this. Okay, so I've got these two services in here now, and they're version 1.0, and they're actually not changing. The only thing I'm going to change is the application. So the application version is now going to be 2. So we'll just go and change that to 2. And that's going to let Service Fabric know that we now have a new version of this thing. Okay, so notice I'm not changing anything else, just the application version. Now that I've done that, I can package this up finally, and this time it shouldn't fail, if we're lucky. Yeah, let's do that. Okay, great. So that'll build there, and there it's packaged. And let's see. Okay, so this is going to go and do a little bit of ASP.NET packaging. Okay, ASP.NET takes a little while to build. But all this is doing is it's just compiling, and it's going to build that application package. Now, what I'm going to do when I do the upgrade, since I didn't change the job service, but I am upgrading the application, I don't actually want to touch the job service. So I want to leave that thing alone. I don't want it to restart. I don't want Service Fabric to touch it. I want it to leave that alone because I didn't make any changes to it, okay? So there's a technique you can use for that we call differential packaging, and it's very simple to do. All you got to do is delete the thing out of there. So I'll show you what the actual package looks like here. If you go into, here's the application, here's the compiled package, and you can see I have my 2 service packages, my application manifest is there, and if you go into the service package, it's made up of a couple other directories. So since I didn't make any changes to this guy, I'm actually just going to delete it out of there. And this is how you do a differential package, okay? So this is telling Service Fabric, yeah, that thing's not in there, so don't touch it, don't restart it, don't do anything to it. And so now that I've done that, what I'm going to do is I'm going to go and deploy it through PowerShell here, okay? So it's the same set of steps. Now, you'll notice here we're not doing a create step. And you see this in Visual Studio. When you deploy through Visual Studio, there's always a create step. And that's the, I'm doing a deployment time. At deployment time, I actually want to create an instance of the application. We're not going to do that step here. So we'll just go and run this one. And so all this is doing is registering version 2 of this application type. And once that's registered, we'll be able to see it on SFX here in Service Fabric Explorer. So now you can see it's the same application type, but it has now 2 different versions, okay? And you can see down here, I have a named instance of version 1 running. So version 2 there's nothing running version 2 code yet. I'm only running version 1 code right now. I'm not running version 2 code. So I can do the same thing, and I can just provision this guy here. So we'll create an instance side by side of number 2, and we'll call this one. Let's say this is a beta. So I've just released a beta version of this, and I'm going to go and create an instance of that. Okay. Now I got these 2 guys running side by side, and the only difference is my new one. If I go into the new one here, you can see. I have the option now of creating this web service. And you notice that it has no services running. So there are no jobs running under version 2. I only have jobs running under version 1 right now. That's the only thing running. So I'm going to go and create an instance of the web service now. And we'll just call it, what, web maybe? How about, yeah, web should be fine. Okay. So now we got an instance of the web service, and if we go into here, once this thing spins up, so what I've done is I've just created a little UI, and through this UI, I can create more job services. Why not? It's the same thing I was doing through PowerShell earlier and through SFX. I can now do it through my own UI, because all these APIs are public. All these management APIs are public, so I can actually go in here and I can say, I'm going to create a job, and I'm going to call it from web UI. I'm going to go and create that, okay? And that's going to create a job, I hope, unless I broke it. Yeah, maybe. Maybe it doesn't work in Internet Explorer. That's a possibility. Let's try Firefox. It works in Firefox. All right. You have witnessed a historical moment. Okay, so that creates a job. So it's a web API application. So what I'm doing here is I'm using the C# APIs now, okay? So it's just web API. I have a controller here, and I'll show you how this works real quick. It's very, very simple code. We have this thing called Fabric Client. This is what you use in C#. And I literally can say, so this is a web API route. It's just an HTTP call that I'm making. And I'm doing this here. I'm saying, here's my stateless service description. And you can see I've called it, it's the service type name is service job, stateless job service type, which is what I had registered originally, right? So this type is already registered. And then I just say, go and create new service. Okay. Create service async. Cool. So I can do this from C#. So now I have my own service, kind of like the way SFX works, but I wrote my own service now that can then go create other jobs. So now you got an application where I can have users come in to my web UI and say, I want a new microphone. That was great. Okay. Let's say
Yeah, move it higher,
did I
I
just
think.
break it entirely?
There you go.
There you go.
You're
Okay.
good.
Let's say I run a microphone business, and every time I want to manufacture a new microphone, I want to track it. I want to track that job, and I'm going to create. Can you guys hear me? Yeah, not so much. How's that? Is that okay? All right. Maybe I'll use yours. I'll just kind of talk into yours. Like
No. It's weird, man.
All right. All right. Let me try turning it off and on again.
You know, the whole session's being recorded. We got the IE thing and this whole thing.
How's that? Is that better?
Yeah, it's
Okay,
better.
fantastic.
All right, you're
All right, so I'm tracking the job of creating microphones, and so that's great. I can just create those jobs. Now, here's what's cool about this is Service Fabric is actually doing the management of this thing. Okay, so you notice in my controller here, I only have two simple things. I have one thing to create a job, and then I got this guy, which is just a HTTP GET that goes and does a query. So all these queries are built in. There's a very, very rich querying API I can use here to go and get a bunch of information out about Service Fabric. So I'm using that to build the list. So when I write out this list, I'm basically just asking, hey, Service Fabric, give me all the services that start with this /jobs, and because I know those are mine. But I'm letting the Service Fabric do all the work. So it's managing the services. You notice that I don't actually have to write a lot of code for it. I don't have to even implement create or delete if I don't want to, because those actions are already there. And Service Fabric does all the jobs it does all the work of creating the thing, figuring out where to place it, what node to place it on, where it can run. All that work is taken care of for me. So I got these two guys. I got this thing now running. This is 2.0. And if I go back here, I'll say, OK, everything looks good. I can create jobs. Now I want to take my original 1.0, and I'm going to upgrade it to 2.0, okay? So I'm happy with the way it works. So I'm going to go into PowerShell here, and let's see. Here it is. Okay. So here's the upgrade command. And so what this says is, now you notice, again, this is targeting a specific named application instance. It's not going to go and upgrade every single application that has a type. I'm specifically targeting one of them. And this is actually important because if you have a situation where say your users, every time a user comes to use your product, you create an application instance for them, and that's what runs whatever thing it is that you built. Now you can, since they each have their own named application instance, you can target specifically which users you want to upgrade when you come out with a new version. So if you have users that want to get into like an alpha program or something like that, you can say, all right, you're in this special program, I'm going to upgrade you before anybody else. And again, Service Fabric manages most of that for you. Now, when I go and do this upgrade, this is going to be a rolling upgrade, and you'll see I got a couple things here. I call it monitored, okay? And monitored means that we're doing health checks along the way. So as the upgrade rolls through, I'm going to start it now so you can actually watch it in progress as I talk. Here you go. Okay, so now it's just starting. PowerShell says, yeah, it's just upgrading. And you can see my V1 over here is now upgraded. So it's proceeding through upgrade domains. Upgrade domains just means it's just a grouping. It's a group of VMs, so it takes one group of VMs at a time, and it does the upgrade. And when I say monitored, what I mean is that when you do the upgrade of one of those upgrade domains, wait a little while and check the status of the application. Make sure it's healthy. And we have some health checks that we can do. We can tell, for example, if your process is crashing over and over again, that's an error. If you're in a quorum loss state or something like that, that's an error. But then you can also report custom health also. So there's just a C# API. It's literally called report health, and you can say I'm in warning now or I'm in error now. And that's to test your own business logic. So if I had messed something up, if I had an error somewhere, I can do some error checking of my own and report error back to Service Fabric. So that's what that monitored thing means. And then we have there's this action, failure action, that says, well, what do I do if there is an error? And so I have it set to rollback. And rollback means that it's actually going to automatically, on my behalf, it's going to roll the entire thing back to version 1.0 again. Okay, so it's completely hands-off. So I ran that PowerShell command, and then I can like go to sleep or something if I want, because it's just going to do the upgrade, and if something gets messed up, it's going to roll it all back for me automatically. And so you have a few options. We prefer doing automated rollback because we like automation, but you do have options too. You can do this all manually. You can choose what you want to do if an upgrade fails or if a fault domain fails, things like that. Okay. So that's how upgrades work. That's how you do rolling upgrades, and that's how you can do side-by-side applications. Now let's talk about something a little different. And we're going to come back to this demo one more time at the end, and I'll show you something really cool with it. Now, quick recap. I'll go through this real quick. So here's what we started out with. I started out with version 1.0 had one service, version 2.0 had two service types. Of course, obviously, if I wanted to go to a 3.0 and say I wanted to upgrade one of the services in there, I could. And here you can see, this is actually just a screenshot from SFX, but here you can see what the application is. The application is this whole thing. It includes all of the service types, and then the service is just this one piece. And then within the service, I have additional packages, and these are just the way that we kind of describe what a package is. The code package is actually your executables and your DLLs and all that good stuff. I won't get into too much detail there. But you can see I can take just this one service if I wanted to, and I can say I have a new version of that, 2.0, and you can see how this rolls up. Right, so the code package has its own version, which rolls up to the service version, which then rolls up to the application version. And so the idea is that if I've changed anything at all inside this application, that's a new version. It's a new version now because it's got some change in it, and that's the roll up that goes all the way through like that. Okay. All right. So just a quick recap on what these things are. So the application, again, this is the logical grouping of services. This is the upgrade unit. This is what you target an upgrade, and this is the thing. This is actually the only thing that can have versions side by side. Services, you can't have two different versions of the same service type in the same application with two different versions. You cannot do that. You can only do that at the application level. So that's where that difference comes in. That's why it's important. All right, and then just a couple notes when you're composing these applications. Again, pretty much just a summary here. All these things sort of roll up to the application level. So something to think about when you're composing these things. Let's talk networking.
Okay.
Go.
Okay, so as a software engineer, I'm constantly looking at, so I want this feature. In order to get this particular feature, what is it going to cost me? And then I do an analysis to say, okay, is it worth the cost in order to get this feature? So when you take a monolithic service and you break it down into microservices, what you're really doing is you're going to take what used to be a method call like this in your monolith, where you would call some method, you'd pass it some arguments, and it would return back your result. And you're going to turn that now into a network request that's going to go across the wire. And people don't, from my experience, people don't fully appreciate the cost of this. They think, oh, we're just going to replace the method call with a network call. But it's substantially more expensive. So in order to do it, the first thing you got to do is you have to define an explicit language-agnostic multi-version API contract. Because your service is going to be version 1, version 2, version 3. And you have a client that may be calling version 1 of the API or version 2 of the API, and you're going to need to maintain backward compatibility because you can't really update the clients and the servers at exactly the same time in any given system. So and you want it to be language agnostic so that you get one of the benefits of microservices where the client and the server are written in different technology stacks like .NET and JavaScript, for example, for Node.js. And when you switch from using some kind of API like this method here to something that's going to be a network request, you're going to lose things like IntelliSense, and you're going to lose refactoring in Visual Studio if you use tools like this. And you're going to lose compile time type safety. Right? So you're going to get this benefit of microservices with the 4 things that I showed you earlier, and it's going to cost you this in order to do it. Are you willing and prepared to take that cost? And I think these costs are pretty significant. They're pretty high. In addition, when I call this method, I'm passing in arg1 and arg2, whatever they happen to be. But in order to send them across the wire, I'm going to have to serialize them. So that's going to be a performance cost. It's going to be a memory cost. And of course, the data types that I'm using have to be serializable. Then I need to send them to the other side, and then the other side is going to go and deserialize them, which will be a time cost and a memory cost. And they have to be able to deserialize it, right? So you're changing it from one form, like a .NET class object, into maybe JSON or XML to send across the wire, so then you can then turn it into some other form like a JSON object in JavaScript or deserialize it into Java on the other side. And then, of course, when the result comes back, you have to do the same thing. The result has to be serializable, and you have to go through this transformation, which again is going to be a memory hit and a perf hit, and it's going to restrict the data types that you can use for making these requests. And if only that were it, but the story gets substantially worse. Okay? So let's just do a quick comparison of making an in-process call to a method as opposed to making an HTTP request or some network request going across a wire. So I've already mentioned several times that the performance is going to be worse and it's going to increase network congestion. So if you're using the network for other things, now you have more traffic going across the network, so your network congestion will be increased by that. When you make network requests, they are unpredictable in time. So now your latency has gone up as well. If I make a network request, what if the server's not running? Right? In a monolith, it's running. Right? You're in the same process. You don't have to think about it. But if you're making a network request, well, there might be network congestion slowing you down. And what if it's not running? Or what if it takes an hour before it responds to your network request, before it replies back to you? How do you deal with that? So a lot of times people try to deal with that by using timeout values. Well, I'll make the request, but if it doesn't reply in 1 second, I'm just going to fail the request. And you can do that, but that can also be challenging too, especially in the face of retries, which is coming up soon on my slide here. And so you might end up wanting to use things like deadlines instead, right? I'm processing a client request, and I need to have it completely finished in 5 seconds. And so I've made a request, it took 1 second, well, now I only have 4 seconds left. And that's an easier way to manage timeouts, is by working with deadlines instead. Network requests are unreliable, right? The network is always unreliable, and you have to consider it as such. So that frequently means that you'll be introducing retry loops into your code. I've made a request, the server came back and said it was busy, I want to go and loop around and retry the request again. And you might want to use some kind of exponential backoff with that, right? I mean, do you see the pain? It's phenomenal pain when making network requests to really do this in a resilient, robust way. You probably also want to use a circuit breaker pattern so that you don't start denial of servicing your own services by constantly retrying over and over and over again. So that's something else you would have to learn and incorporate into your code base. And if you're doing retries, it's possible that the server did get the request and is processing it, but your client-side code timed out. So if you do a retry, then you might be sending the same thing to the server, and now it might end up doing it twice. So you have to make sure that the server code that you implement is idempotent, to make sure that there's no ill effect if it does the same operation twice. These are all very challenging things to really get right when you're building a microservice. Then, of course, since a microservice is sitting on a network somewhere, it's really callable by anything. An in-process call is only callable by the code that linked the DLL, but a service sitting on the network could be callable by anything that has access to it. So now you probably need to introduce things like authentication, authorization. Maybe you want to encrypt the data that's going across the wire in case other things are sniffing on the wire. Whereas when you were all in process, you didn't really have to think about these issues. And then, of course, your debugging of the situation, of the system becomes more complicated. What if there are network issues, and that's why things are failing? How do you look at performance counters, events, logging information, where some of the processing is happening on one service, some of the processing is happening on another service, which may go and call a third service? And how do you aggregate all those logs together and make sense out of it? And then you might want to have some kind of causality ID or call stacks that go across all these different services, so you know how you got to this place over here where there was a failure, which other services did it pass through before it got to you, right? All these things are additional challenges in order to get those 4 benefits. So this, I think, is really, really hard to get right. Really, really hard to get right, which is why microservices should be very carefully considered. And if you are getting one of those 4 benefits, at least one of those 4 benefits I mentioned before, and that benefit's really important to you, then going down this path can make sense. Otherwise, you might just be better off with a monolithic service. Or maybe just have a few microservices and more monoliths as possible. It doesn't stop there. Yes, I know. The next part is service endpoint discovery. So now you have some kind of cluster where services are being created, and those services are listening on ports. Well, how do the other services know in the cluster on what port the things are listening on? How does it know where they are as a network address, IP and port, so they can go and communicate with them? And in this world of building distributed, reliable services, services start and stop. You saw Vaz, he's dynamically creating services whenever he wants to start a new job. Each of those services he dynamically creates could have its own endpoint to it. So you have to discover that endpoint somehow so you can go and talk to that service. You might want to scale up and down services. In the holiday season, When more people are buying things, you might want to scale up to 100 nodes to run your service. When the holiday season's over, you may want to scale down to only 50 nodes. So these service instances, each 100 of them has different IP addresses or endpoints to listen on. When you scale down to 50, 50 of those endpoints are no longer valid, they're gone. And of course, services may crash, a node may go down, a router may go out, a power supply may fail, a hard disk can fail, right, in this world. Now, Service Fabric has built-in mechanisms to detect those kinds of things, and it can move a service from one node to another, or if a node goes down, it can create another instance somewhere else. So that means a valid endpoint is no longer valid. A new service comes up with a brand new valid endpoint. So endpoints for services are changing and are very fluid in this kind of world. So each instance creates its own endpoint, and they are typically dynamically assigned IP addresses and ports, and so you need a way to discover these so you can go and talk to the services. So clients have to dynamically discover the instances. I'm not going to say that other part, but that other part just makes it worse. It's just another thing that makes it, all right, I'll say it. So, okay, service is up and running, and it has an IP address and port. This service over here discovers the IP and port. And then before it goes and calls it, this service goes down, another service comes up, and it's assigned the same IP and port. So now this guy thinks he's talking to the first service, and now he's talking to a different service. And that can happen, and I think it's a ticking time bomb for a lot of people when they build services, that they all of a sudden start sending data to a service that isn't the one they originally thought it was. And that's another thing that just makes this more complicated. So the way we typically try to deal with these kinds of issues is when you stand up a cluster, you end up with something like a service registry service. Now in Service Fabric, we call this the naming service. And it basically is a dictionary of key value pairs where the key is the name of a service or a service identity, and the value is its endpoint. Then you can stand up some other service in here. So here I'm standing up a website service, which is some microservice, and you can have one or more instances of that. Then I stand up some other internal service in the cluster. I can have one or more instances of that. So let's just say that each instance has its own endpoint. So when it comes up, it goes to the service registry or the naming service and says, I'm internal service number 1, instance 1, and here's my endpoint. And the other instance, let's say there's 2 instances, would say, I'm service number 1, instance 2, and here is my endpoint. Then we could stand up another internal service in the cluster as well. So this is internal service number 2, and let's say we have 2 instances of it, so we also have 2 more entries in the naming service or service registry for the 2 instances for service 2 and what their endpoints are. So now this service registry has all this knowledge of all the instances running in the cluster and the endpoints that you would use to communicate with them. So now we'll put a load balancer in front of this. A client request will come in from the outside world, hit the load balancer. The load balancer will direct the traffic to the website service. The website service then wants to go and talk to an internal service, number 1. So it goes to the service registry and says, hey, I'm looking for this instance of this service. The registry says, well, here's the endpoint that you can use to talk to it. That gets sent back, and then it can go and talk directly to the endpoint of the other service. Right? And so this is one way of dealing with these kinds of mechanisms and doing this kind of endpoint discovery. Okay. Now, this can be rather challenging, and so what we have worked on with the Visual Studio team at Microsoft is we are currently in the process of creating a new Visual Studio template for Service Fabric that encapsulates some of the solutions for this problem into it. If you look at the code at the bottom here, and we make this available for you to download now. It's not as a Visual Studio formal template yet. We're trying to get feedback from customers on it to see how they like it before we put it into the Service Fabric SDK proper. And this HTTPS here on GitHub, that's where you can download all the source code for this and where you can try it out. And if you look at that, you will see that somewhere in that source code, we are saying to you, well, you can use an HTTP client to do your communication from one service to the other. And then we're using this feature that's built into the .NET HTTP client of creating these filter handlers. And so we have written for you a circuit breaker HTTP message handler. And that will give you circuit breaker pattern support built into your HTTP requests so that you don't start denial of service attacking your own microservices. And then that gets wrapped around an HTTP service client handler, an HTTP service client exception handler, and an HTTP service client status code retry handler. And those 3 handlers are about doing re-resolves. Like you make an HTTP request to the service and it's not there anymore, we will go back to the naming, these filters will go back to the naming service, get the latest address, and then go back and retry the service again. So it will do automatic retries for you and automatic re-resolves of the endpoints for you. And then just for fun, we also have an HTTP trace message handler. This is a way for you to get tracing to flow throughout your HTTP requests from one to the other to help with the debugging story there. So I would encourage you to take a look at this, download this code, experiment with it, and we would love to have feedback on it before we put it into the product proper. Another thing to consider about networking, always fun topic, is about load balancer probes. People they basically ignore the load balancer. Once they set it up, they kind of set it up and they forget it. But there's a lot of interesting stuff to do with the load balancer. So let's just first talk about how the load balancer works. Here I have 3 different virtual machines, VM1, VM2, VM3, and the load balancer knows about those 3, and we've set up a load balancer probe so that the load balancer will end up probing all 3 of these VMs every 15 seconds. So when the load balancer sends a probe to those VMs all return HTTP 200, and that tells the load balancer, all these VMs are fine, you can direct traffic to any of them. But then let's say that VM number 1 over here, it's about to do something and it would like to not have new traffic sent into it. One example is, let's say the VM1 code is about to do a generation 2 garbage collection. Those can be very expensive in time. And so you might like to tell the load balancer, don't send me any traffic right now until this generation 2 garbage collection is complete. So you can know, there's a way with .NET where you can find out when a generation 2 garbage collection is approaching. And when that event fires, you can go and say in your code, the next time the load balancer probes me, let me return a 503. Really, all you have to do is return not a 200, anything but 200. So now I've set this to 503, so on the next load balancer probe, it's going to get that 503, and then the load balancer is going to say, okay, I won't send any more traffic to virtual machine number 1. So any traffic that comes in from the outside world can only be sent to VM2 and VM3 right now. Then after the garbage collection is complete, you can reset VM1, so the next time the load balancer does a probe, it returns 200, and now it's back in rotation. And there's a lot of cool stuff that you can do with this, and it ends up giving your customers a better experience when using your service, because you don't want the load balancer to send traffic to you when you can't really handle it. This is a way to get the load balancer to avoid sending you traffic at bad times. It could also be that a machine goes down. In this case, my VM2, for whatever reason, maybe my service went down or it's not responding to the network. So when the load balancer sends a request every 15 seconds, if it gets no response at all, it assumes it can't send traffic to it. And that immediately takes it out of rotation so that no traffic will be sent to that VM. If that VM starts responding again, it still keeps getting probes every 15 seconds. So if it comes back to life, then the load balancer will direct traffic again.
All right. We're getting low on time, so I'm going to breeze right through this.
Go for it.
This is just because this has gotten awfully confusing lately. What is the state of the web on Service Fabric? What do we support? What don't we support? So what you see here is essentially what you can do on Service Fabric. You can do ASP.NET Web API 2. You can do ASP.NET Core 1 MVC. Those are really your 2 options. And then these are just kind of the stacks that they're built on. So if you're on Linux, you're probably going to be using Kestrel, because that's the only one that doesn't depend on the Windows Server HTTP API. But if you're on Windows, then either of those 2 are fine. In fact, we do have a recommendation, or rather a prescriptive recommendation. These are your options for web servers. We don't support IIS. You may be able to do IIS inside a container, but just kind of as a regular service, IIS is not supported. And so what we recommend today on Windows is use Web Listener. And this is currently in RC2 from the ASP.NET team, 1.0 RC2, and the RTM should be out fairly soon. So just something to know. And let's go on to resource balancing. So we got 11 minutes. You want to jump right to the demo?
Sure.
All right. Okay. Here's the thing you've been waiting for. This is the cool part. I know the whole thing was cool, though.
Yeah, I was
All right.
really insulted there.
Yeah, all right. Well, this will be cool after all your gloomy, everything is hard. I'm going to be the good cop
Yeah,
now.
you end on the good stuff.
All
The
right.
networking stuff's
All
tough.
right. Okay. Yeah, so we don't have much time, so let's do this. Okay, I'm going to go in here. I'm going to delete a couple things. I'm going to delete this V2, the beta. I'm going to get rid of the beta. And notice, again, I'm just kind of doing this. This is, again, talking to the cluster over HTTP. I'm going to say delete that. and then I'm going to go into the original one, and I'm going to delete these two services as well, because I don't want them anymore. They're done. My microphone came. We're good. All right, so we'll just go and delete them. Now, what I'm going to show you is, so we had a situation where we were kind of, we were kind of proposing this as a solution to a problem, and then we were asked this question: what do you do if, say you're creating a service per customer? What do you do if like this big shot customer comes along and goes, hey, I need my job to have a dedicated VM all to itself, all right? So there's different ways you can do that. It turns out in Service Fabric, that's just like crazy easy to do. So it's very trivial. I'm going to show you a slightly different view of things. This is a different tool. This isn't in Service Fabric. This is just, again, this is the kind of UI you can build using the Service Fabric management API. So this is something I built in Angular a while back. And it's just, what this is going to show you is a visualization. So I got all the cluster, I got the whole cluster here. It's a 7-node cluster. I got my 7 nodes up there. And so what I'm going to do is I'm going to use a feature in Service Fabric called capacities and load metrics. So what I've done, I've pre-configured this cluster so that each node has a capacity that I invented. I made this up. I invented a thing called work units. And I said each node is going to have 100 work units, and that's its capacity. Okay, so that's how much you can run. Now, when I did the UI here, you notice I had this thing called job units. And so what I can do is when I create this named service instance, I can say how many job units that thing takes up. And a job unit it's just something I made up. It can represent anything you want, and maybe it represents how much money your customer's giving you. It doesn't matter. But you can do anything you want, right? So what I'm going to do is I'm going to create a new one here. Let's call this one, I'm going to call this one a medium job. And I'm going to give it 50 units. Let's say this is number 1. I'm going to give this guy 50 work units, okay? And then I'm going to go and create that. So let's see when this thing pops up. Now, go back into here, if it's still working. Oh, I'm in the beta. Sorry, I got to get off the beta.
Yep, you're still there.
Am I still there?
Yeah, it auto-completed it, but.
Auto-completed, huh? Firefox is smart. It's just kidding. Should I switch to Chrome now or what? All right, I guess it'll take a second to load because I haven't done. So what I'll do, I can actually do it through PowerShell too. So this is the nice thing. I have it all in PowerShell as well because who knows. So here it is. So I got this thing called work units, and when I go and create an instance of this service, I can actually say, here's how many work units I want this thing to run with, and I can give it a number. So I'm going to make this one, this will be my medium job, and I'm going to give this guy 50 work units, and I'm going to create it that way, okay? So here we go. So this guy's taking up 50 work units, and each node in the cluster has 100. So now, here he is. Now I'm going to switch to a slightly different view. So what you're seeing here, this is drawing it to scale. So the vertical black bars represents the capacity that the nodes have, and the blue thing, that's the service instance. It got placed on a node, and it's drawn to scale based on the metrics it's reporting. So it's reporting 50 out of 100. It's taking up half the node capacity. So what I'm going to do is I'm going to create a few of these. I'm going to create a couple new jobs, and this guy doesn't want to load, so we'll just do it through PowerShell. So I'm going to create another medium job and run that. And then I'm going to create, let's say, how about we'll make a tiny job, and he'll have, let's give him 10 units. And then we'll create another one with 10 units. Okay. And then I'm going to create a couple small guys, and they're going to have 25.
Small job 1?
Small job 1, small job 2.
There.
Oh, that's okay. We'll just do a 1 here. There we go. Okay. So I can just create these things. Now, normally I would be doing these out of the web UI, but we can do it this way too. That works fine. I don't think it created the last one, did it? All right. Let's try that again. Go. There it is. We'll do another one. Okay. So we'll just create a bunch of these guys. Now, go back to our cluster. So now we got a few different sizes of jobs. So Service Fabric right now, what it's doing is it's just finding a place to go and place these jobs that I'm creating, okay? And ultimately what it's going to want to do is it's going to want to try to keep things balanced. And by balanced, I mean that those vertical bars coming down, the blue ones, you should be able to draw a straight line across, and they should all come down to the same point, right? So that's what we mean by balanced. Okay, so now Mr. Big Shot comes along and says, all right, I want a job that has a dedicated node all to itself, but my nodes are all full of other jobs. So what do I do? Well, what I'm going to do is I'm going to let Service Fabric do the work for me. So here comes the big job. And he's going to get 100 units. So we got 100 capacity, and I'm going to give him 100 units. So what that's going to do, what do you want? Oh, I missed the end. There it goes. OK. So now Service Fabric's going to look around, and it's going to say, I need a node that has 100 available units for this guy. Well, I don't have one, so what should I do? It's going to start moving things around. So it's kind of looking at the cluster, it's running some computations, it's sort of doing a simulation. And eventually what it's going to do is it's going to take these guys and it's going to kind of reshuffle them around, okay, based on the capacities that I've set and what I've asked for. So here, it's now found a place for it. And it's going to place it on this node, and it's going to take the other guy, and it's going to move him off. So he's actually quitting right now. So he's going to move there, you can see. Okay. Now what's interesting is that Service Fabric automatically found the best way to keep this thing balanced. It took the two smallest ones and grouped them together, rather than taking maybe two of the medium ones and grouping them together, right? So it's trying to keep it as balanced as possible. Eventually, this little guy will go away. He's just getting shut down. Now, let's say Mr. Big Shot comes back and says, all right, I got one node all to myself, but that's not really enough to run my workload. I need 3 instances of my big job, and I need 3 dedicated nodes to it to run it. So, again, real simple. Here's what you can do. We're going to go back into PowerShell. And I got the big job here. I'll make sure that's the right name. OK, it is. And this is what we call an update. It's slightly different from an upgrade. An upgrade says, I've got a new version of code or something like that, and I want to actually upgrade the whole thing. The update is slightly different. When I go and create a named service instance, I provide certain parameters. And you saw that earlier in the show here. The update basically says those parameters that I provided to you earlier, I can actually go and change those. So I created it initially with just one instance. You can see it down here. I said instance count 1. Well, I want to go and update that to instance count 3. Customer asked for 3, so I'm going to give him 3. I'm going to target just his service. I'm going to run that, and that's going to change that now to 3. So again, same problem. Service Fabric looks around and goes, well, he's asking for 2 more instances of this giant thing that wants to take up all the capacity of the node. And so it's going to, again, shuffle things around. It'll move things around to find a place to put it. And here we go. So now it's found a place. It's going to take this guy. And again, you notice it's not actually touching the median job. And see what it just did there? It's keeping this line as straight as possible. So it went and grouped these guys together now over here. These are running, by the way. This is running code. It went and grouped these guys up together because that was the best way it could figure out to keep the whole thing balanced. So now we got 2 going. And then it's going to try to shuffle things around a little more to create that 3rd instance. And it looks like we are out of time.
We got 2 minutes and 20 seconds.
Questions?
OK, fine.
All right, so we'll let that run. And I think that was the end of the slide deck, too, so we could probably take questions at this point.
I think so. Sure.
While it's running. So Service Fabric is going to keep computing, and we're happy to take questions at this point. Hey, there it goes.
Yes. The question is, am I going to write a book about it? My current thinking is no on that. The technology changes pretty rapidly, and we put out a new release about every 2 months. So the process for writing a book is time-consuming, so I don't think that's going to happen. But thank you for asking. Yes, over here. Can we turn up the house lights now, maybe? That would help me. How easily can we integrate Service Fabric with the API management?
I mean, they're separate products, but it shouldn't be too difficult, right? So in Service Fabric, you're going to expose some public endpoints, which are some web endpoints, and you literally just point API management to that. Yeah, they don't actually know anything about each other. So usually what you have is in Service Fabric, you'll have a stateless service that exposes some well-known endpoints that your customers connect to. You can use API, if you have a multiple of these stateless services, all with different kind of endpoints, you can use API management to make a nice single seamless layer on top of that for your users to connect to. But it won't be able to do service discovery for stateful services or anything like that, no. It doesn't have that integrated. Yeah. Yeah.
Yes?
So this metric that was used by Service Fabric to reshuffle these services, can it be dynamic and reported by something?
Yeah, so the question is about the metrics, if you can report them dynamically, and yes, you absolutely can. So you can do two things. You can report first up front when you create it, you can give it an initial load, but you can dynamically, there's an API call that says report load, and at any time while it's running, you can continue to report load. So these jobs that I've created here, they can actually change in size over time if I programmed them to do it that way, yeah. Yeah, absolutely.
We have services written in other languages like Java.
Oh, would you mind using the mic? It's like right next to you there, yeah.
It's written in other
Use the
languages.
mic so it gets recorded.
Hello? Yeah.
Yeah, gotcha.
Okay. So we have services written in other languages. Can we use the service registry and discovery to find the services through that mechanism? Or
Yeah,
okay.
the naming service in Service Fabric has a
Yeah.
RESTful API to it, so
Okay.
you can, from any language, just make a HTTP RESTful call to it to go and get the endpoint information back.
Okay.
Yes.
Yeah.
Do you guys have any recommendations related to multi-region? Is there any way to have like a load balanced service cluster that's in different regions in case there's some kind of disaster in one Azure region?
You want to handle that
I'm
one? or
sorry,
you
can
want me
you
to-
repeat that?
Yeah, sorry.
A recommendation for doing a
different
cross-region
multi-regions.
deployment.
Oh, for multi-region deployment. Yeah, it's so we don't support that in Azure yet today. It's something we're definitely working on. Service Fabric itself, the software actually doesn't really care where your VMs run. They just have to have connectivity between them with low latencies. So that we don't have a way to do that in Azure yet, but it's something we're working on, yeah.
In the upgrade scenario of a stateful service, does the reliable state remain across versions?
Yes?
Yeah.
Okay.
Yeah.
Yes.
All right, thanks.
The state is version agnostic. Version agnostic.
We actually looked at how the services were upgraded, independently or individually, right? But what's the DevOps story on this? So how do I automate this whole thing?
Well, we have, as Vaz was saying, we have PowerShell commands and we have management APIs that are available. So creating administrative scripts or things like that to automate it should be pretty simple and straightforward.
I mean, I have to write this whole thing, right?
Well, I don't know what you mean by whole thing, but you saw him using the PowerShell commands. They're fairly simple. So you could be polling some, CI service, and when there's a new build there, you go and execute a script that just does a PowerShell command that uploads the new version and then does an upgrade after that. And so that would basically be, it ends up being about 3 PowerShell commands to do that. So yes, you'd have to write those 3 whole lines.
Thank you.
We have many examples of them, so you could copy and paste as well
I'm hoping so.
to reduce some of the keystrokes that are involved in that.
Hi, what's the best thing to do with the ETW logs? They're just like lines of text, aren't they? I mean, can you mark that they're errors, or can you, is there somewhere you like to send them so you can search them, or what?
Yeah, I mean, the recommendation right now with the ETW is to upload them to Azure Diagnostics, which just puts them in table storage, essentially. And then from table storage, you can read them out in like Elasticsearch, Elk, or something like that. But it's really, you bring your own, as far as like doing some analytics over your logs and stuff like that, it's really, you bring your own solution externally from Service Fabric. ETW is just a way to get them out. And then we have Windows Azure or Azure Diagnostics agents that will upload them automatically to table storage for you. So at least you'll be able to collect them all into a central place. And then you put something on top to read them.
Cool. Thanks.
At this point, we're 3 minutes over, and the other presenter is here ready to set up. So we'll take more questions outside the room.
Yeah, let's do that. Cool. Thanks, everyone.
Well, thank you.
Appreciate it.